next up is Hadrien from Sismo, but he's... Yes! You do not want to see what Telegram is like right now. Where is this dude?
Oh, yeah, really?
Yeah.
Okay, sorry for this.
You made it. Cool. Well, I will leave you to it and enjoy.
Thank you. Hi, everyone. So today we're going to talk about data aggregation and selective disclosure. And hopefully you'll learn that privacy is not only normal, but it's really powerful. I'm going to start to speak about personal data. I think that we are all aware that in Web 2, it's app-centric. As a user, I can access an app, and then I do interactions there, and I build up my identity that is stored on their servers. So I'm not owner of my data, I'm lending an account. So problem of ownership, but there's another problem. I'm doing the same on multiple apps, and my data is isolated, is siloed. And so here, for instance, you cannot leverage your identity within Facebook or Twitter at the same time. So we have this issue in Web 2. In Web 3, it's different. We have data ownership. It's centered around the user. So here, it's more, I have my account, my sovereign account, and I bring my identity to the applications. So here, I have a wallet, and I use Uniswap with my data, and it's my account. But we still have a similar problem because I would use Uniswap more on my private wallet that I act like a bank account. But then when I want to use like social networks like Lens, I would tend to use my ENS doxed account, my public wallet. And advanced users, they tend to have multiple wallets for different use cases. And so we realized that actually you are recreating the silos that we're trying to avoid. So what's the problem? Is that we want to use our social capital at once. We want aggregation. We want to be able to prove to someone, hey, I'm solvable, I have some good financials, but at the same time, have a good reputation on that system. And that's something that we can't do. First reason is that we don't have ownership of the data. It's stored on the servers in Web 2, so of course you can't use it. It's their most important asset, your data, so they keep it for themselves. But even in Web 3, where we got the ownership, because of the lack of privacy, we don't use that as an aggregated manner. And the solution to this problem, that's our vision at Sismo, is to have aggregation at the local level, at the user level. So as a user, I'm able to aggregate all my accounts, my Web 2 and Web 3 accounts at once. I'm the only one that can see the aggregated view. So I see my entire social capital. And then, thanks to selective disclosure, I'm able to leverage it anywhere. So that's what we do at Sismo. Sismo is a communication protocol between users' personal data and applications. So again, the user is able to aggregate all its data, their data locally, privately, and then reveal it to applications as they will. So we have two concepts. So here we'll take the user side. So as a user, how I'm using Sismo, I have access to this data vault. That's the private local storage, where I import, let's say, my Hadrien.eth account, my public wallet that I use on all public things. That's my public silo. And then I also import my private wallet, the one on which I use Uniswap, or I use Tornado Cash, for instance. And I can also add some other data sources, Twitter, GitHub, and soon many others. So all of this is stored in my Sismo data vault, my local aggregated identity. Then, so that looks like this. Here we see a data vault that has some wallets, Twitter, GitHub. And then from this data vault, we'll leverage ZK keys to selectively disclose what I want. So technically, how it works, ZK proofs work with the following concepts. You have a prover, where you generate a proof, a ZK proof. So here, in the context of Sismo, I will generate a proof that I voted in this DAO, that I have this NFT. I'll create a ZK proof of the granular data that I own. And then the application will verify it, and they won't get access any more information than what I shared. So that's how it works. You have the prover in your Sismo Data Vault and you send a ZK proof, and the application will understand that with its verifier. So that's why we are a communication protocol. So that looks like this. We'll get into that later, but here I'm able to prove anything from my Sismo Data Vault, that I own this specific EVM address, that I have this NFT, and other things. So now that was the end user side. Now what about application developers? Because what we serve in the end is application developers. Let's take a look at how today NFT are checked, NFT ownership are checked. It's widely used to use sign-in with Ethereum. So basically the concept is like, I request a signature from a user's wallet, I verify it. So similarly, prover, verifier, here's the proof is signature, verifier is like, I verify the signature. I know that the users own that wallet, and then I check in it. Do I really need the full wallet for this? When I do NFT check, like, let's say that this NFT is on a private wallet, do I really want the private wallet of users? I don't think so. Similarly, and that's even more interestingly, let's say that I want to access 2 types of data for a user, and these 2 types of data are on different silos that I presented to you before. So let's say that I want to check NFT ownership on the asset wallet of a user, and that the user voted on a DAO, and this would be more on his public wallet. Here, the current way of doing it with sign-in with Ethereum would be, okay, sign a message with your public wallet, I verify it, I check NFT. Sign a message from your private wallet, I check in it. And here what I'm doing is that I get access to both wallet addresses, and I'm creating a link between these 2 addresses. And the UX also is not very good, but there are some projects that try to do it, and I think that it's really a bad idea to incentivize users to dox themselves, because they might not be aware of these things. Whereas with Sismo, the way to do that is very simple. It's like, as an app, I don't request a signature, I request a ZK proof. And it's like, prove me that you have this NFT and that you voted in that DAO. I don't want to know your addresses, nothing. So Sismo Connect is the SSO. That is somehow the same stack as sign-in with Ethereum or like sign-in with Google. We're trying to replace all these things with the sovereign single sign-on. So we enable app developers to access any data from the users, any data they imported into their data vault, and with responsibility, meaning that they don't request more than they need. And I think that's at the core of all what we do, is to really like respect the sovereignty of users, and yeah, and we have the tool for this. So with Sismo Connect, if you integrate it as an app developer, what you do, you are able to request authentication from any of the data sources that the user has imported in its vault. So that would be a Twitter account, like prove me that you are owner of Vitalik.eth, Vitalik, or EVM address. So yeah, you can also request some granular data about it, NFT ownership, that you voted on a DAO, and you can also request message signatures. What is powerful with Sismo Connect is that you can request them all at once. So you could request potentially multiple wallets, multiple data, granular data, and a signature. So we're going to take an example of a privacy-preserving gated airdrop that is, by the way, CB resistant. Here, to do that as an app developer, I need to integrate a Sismo button. So in my front end, I will have a button, a bit like sign-in with Ethereum or Wallet Connect. When the user clicks on it, they will be redirected to the Sismo data vault. And here they will say, OK, I consent that this app has access to this granular piece of data. Here, it's Gitcoin passport, so prove that you are a human or that you have some CB resistance, and access that you own a known NFT that would be on your private wallet. So I'm able to do that. So I redirected them to the vault, and then I verify it, and I drop them an NFT. So a bit more precisely how it works again. So you have the ZK drop that has a front end and a smart contract. In the front end, you integrate the sign-in with Sismo button. You do your request. I want my users to prove me that they have a Gitcoin passport and that they have a non-NFT. When they're redirected, they generate a ZK proof. And from that, I get it back, and I send it on-chain. So on-chain, you will send the ZK proof, and your smart contract will verify the proof. And if all is good, then you'll mint the NFT. So that's the flow of Sismo Connect. And it's really simple to integrate. Basically, if you think about it, we are abstracting away all the ZK proofing. As an app developer, you just say, OK, I request, prove me ownership of that account, prove me that you have this NFT, and it's quite simple. So it's like some lines in the front end to make the request, and then some lines in your smart contract to verify it. We have the similar flow for off-chain apps, because if you think about it, like the Sismo data vault is a local thing that is off-chain, and you can create ZK proof. We can verify it both on-chain or off-chain. So here the use case would be, let's say, a gated newsletter, and you require them to give you the Twitter account because you want to have a way to contact them, for instance, and like prove me that you are a Sismo contributor. So similarly, you integrate a Sismo button. Hey, I request that you give me your Twitter account and that you prove that you are a Sismo contributor. And this time, same flow. This time, I verify it in my backend. So we give to app developers client packages so that they can make this request, and backend and smart contract verifiers package so that they can verify the proofs. Yeah, so that's it. So let's do last time the flow. I don't think that I need to repeat again, but it's still the same thing. It's really easy to integrate, and it's secure. So a good example that is live today, if you want to try it out, is for the occasion of this event that is putting an emphasis on privacy. We had this privacy is normal campaign, and we had a lottery for this painting, like on the right, that is in our office. It's a code of Tornado Cash. It's a celebration of privacy. So in this lottery, to get in, you need to prove two things, both that you are a Tornado Cash user or that you were one, and that you have a Gitcoin passport. At the first glance, you might think, it's a bit weird because like Gitcoin passport is doxing, Tornado Cash is super privacy, and so it's not private or something like that. But it's because we tend to think that privacy is like, yeah, I just want to be private, and that's the only goal of privacy. But here, what we want to showcase and demonstrate is that privacy enables you to have to not be all in doxed or private. You can have very well a private wallet, and here that would use Tornado Cash for good reasons, of course, and a public docs one, your ENS, that has a Gitcoin passport. That's all right. And thanks to privacy, you'll be able to leverage all of this data as one. So the lottery, you get in, that's the flow. You can, by the way, access it today on spaces.sismo. You'll see, you can trade by yourself. And if you are not a Tornado Cash user or don't have a Gitcoin passport, you can either do it now, it will be updated in 24 hours, or you can try the demo. Again, what we want to give you today is the feeling that there's a path somewhere that is better than signing with Ethereum or that signing with Google, that is as easy to use. As an app developer, I can request many things, but responsibly. So that's it for my presentation. I have no idea at all about the timing, so I will be very happy to get some questions.
Another time.
Yeah.
Because the schedule is... OK, I got the applause.